The quarter-cubic honeycomb, quarter-cubic cellulation or bitruncated alternated cubic honeycomb is a space-filling tessellation, or honeycomb, in Euclidean 3 space. It is composed of tetrahedra and truncated tetrahedra in a ratio of 1:1. It is called quarter-cubic because its symmetry unit, the minimal block from which the pattern is developed by reflections, consists of 4 such units of the cubic honeycomb. It is vertex-transitive with 6 truncated tetrahedra and 2 tetrahedra around each vertex. A geometric honeycomb is a space-filling of polyhedral or higher-dimensional cells, so that there are no gaps. It is an example of the more general mathematical tiling or tessellation in any number of dimensions. Honeycombs are usually constructed in ordinary Euclidean, flat, space, like the convex uniform honeycombs. They may also be constructed in non-Euclidean spaces, such as hyperbolic uniform honeycombs. Any finite uniform polytope can be projected to its circumsphere to form a uniform honeycomb in spherical space. It is one of the 28 convex uniform honeycombs. The faces of this honeycomb cells form 4 families of parallel planes, each with a 3.6.3.6 tiling. Its vertex figure is an isosceles antiprism, 2 equilateral triangles joined by 6 isosceles triangles. John Horton Conway calls this honeycomb a truncated tetrahedral, and its dual oblate cubicle. The vertices and edges represent a kagome lattice in 3 dimensions. The quarter-cubic honeycomb can be constructed in slab layers of truncated tetrahedra and tetrahedral cells, seen as 2 trihexagonal tilings. 2 tetrahedra are stacked by a vertex and a central inversion. In each trihexagonal tiling, half of the triangles belong to tetrahedra, and half belong to truncated tetrahedra. These slab layers must be stacked with tetrahedra triangles to truncated tetrahedral triangles to construct the uniform quarter-cubic honeycomb. Slab layers of hexagonal prisms and triangular prisms can be alternated for elongated honeycombs, but these are also not uniform. Cells can be shown in 2 different symmetries. The reflection-generated form represented by its Cox-Etterdingen diagram has 2 colors of truncated cuboctahedra. The symmetry can be doubled by relating the pairs of ringed and unringed nodes of the Cox-Etterdingen diagram, which can be shown with 1-colored tetrahedral and truncated tetrahedral cells. This honeycomb is one of 5 distinct uniform honeycombs constructed by the K3 \_8_3 Cox-Etterdingen group. The symmetry can be multiplied by the symmetry of rings in the Cox-Etterdingen diagrams. The quarter-cubic honeycomb is related to a matrix of 3-dimensional honeycombs, Q2P4, 2Q.